discussed in earlier class sections. So we have seen how the eigenvalues and eigenvectors were applied in many real life field. So I think you people have prepared a case study about topic of image processing and where that eigenvalues and eigenvectors in diagnosing the cancers and so on. Isn't it? So let us have a discussion briefly about the case study which you have prepared based on the design thinking framework. Yes? Just come forward.
So, good morning everyone. I am Rachna here with my teammates to present the topic application of eigenvalues and eigenvectors in medical image analysis for cancer detection using design thinking concept.
So, first we are about cancer detection, why it is important in our society. So, society is facing many problems nowadays in cancer. So, more than 30 million people are dying over a year due to cancer. So, our case study is about how we can use these eigenvalues and eigenvectors concept in medical terms for detecting these cancers. So, what is an eigenvalues and eigenvectors? So, from a matrix we are using many formulas and we are getting eigenvalues and eigenvectors. So, in our case study for storing data, we are using this eigenvalues used to store data and eigenvectors are used to connect the where it is stored and location of the eigenvalues. Next comes the Bharatwaj and Devadashini to explain the applications.
Hi, I'm Devadashini. Now I'm going to talk about the medical image analyzing. Medical image analyzing involves computer and mathematical technique to extract important images from like CT, MRI scan and X-rays. It used to detect disease and segmentations. Eigen decomposition plays a major role in analyzing. It is a mathematical tool from linear algebra. Advantage of using the eigen decomposition is removes unwanted noise and gives a clear image values.
And now I am going to talk about the application in eigenvectors and eigenvalues. Principal component analysis. Used to compress image and extract main features. Common in brain tumor detection, lungs image analysis, and in cancer detection. Next we come about image reconstruction. Helps to clear image
We can remove with the help of PCA so that we can get the clear picture noise. Without noise we can get a clear image or clear audio. Yes.
Next we talk about this.
So, as Darshana said, we are using design thinking concept here. So, first the empathize part. So, empathize part we are majorly focusing on cardiologists who are facing problems to detect this cancer detection earlier so that early diagnosis is possible. So, from this is the empathize. Next, the define the problem. So, for defining the problem, as I said earlier, cancer is the main problem in our society. So, for this, our main goal is to find the invisible to visible. So, we are using these techniques. So, next comes the ideate. So, ideate process as Bharatwaj said. We are using PCA concept for PCA concept which compresses the whole information and it can locate the possible area where so that we can easily get this information about it. So, the major concept is here we are using PCA is nothing but we are reducing the dimension without reducing the features of the patients. So, if we are forming a matrix here, first comes the row and the column. For row we are using patients details like phone number or their names, and then for columns we are using just the features like weight, height, body mass and etc. So, from this we are getting as MRI and CT, from this MRI and CT scan we are taking the image. Using PCA we are compressing the image dimension without reducing these features. So, from this we are making a covariance matrix. For covariance matrix we are getting eigenvalues and eigenvectors. From eigenvalues we are getting the reducing the dimension, we are getting the variations that are different from the normal cases. For the eigenvectors we can find the location where these differences are detected in these cancerous cells. So, from this we can these data can be go to the AI, or can if the doctor is good well versed in AI concept, so they can easily diagnose these problems earlier, and they can that treatment can be taken easily. So next, Darshana will tell about the case study. A prototype.
Prototype for the cancer detection. So there are 4 steps. So first one is collect the MRI images for the, it can be any tumors or the brain tumor or lung cancer, anything. And second one is about the so second one is the using of the PCA method, principal component analysis method, to detect the main patterns. And third one is train a simple diffuser to identify where the tumor is. And fourth one is about collecting the images, like every pixels and voxels, and applying on the screen. And then doctors will analyze what is the stage of the cancer or the tumor. Next, Darshan will say about testing.
So in testings there are 4 methods. First, test with new model, test the model with new MRI scan, and then compare the results with the real doctors, measuring accuracy, sensitivity and risk score. And then if the result was good, the prototype will help to detect the diagnosis. And then Darshana will say about case study.
So it is about brain tumor detection. So in brain tumor detection, the doctors and the computers use the MRI images of the brain. So in this MRI images of the brain, they contain lots of data, like every pixel or the voxel has numbers. So to analyze, if we have to detect the brain tumor, we have to use these numbers smartly. That's where the eigenvalues and eigenvectors are used. So in how to use eigenvectors and eigenvalues in this brain tumor detection, there are 4 topics, like 4 points. First one is about reduce the data size, that is using the PCA method. And second one is about the future extraction. And third one is about the tumor detection. And that's all. Next is about the like example. Let's take an example. The MRI images contain like a large table of numbers. So how does eigenvalues and eigenvectors are used in that? So the eigenvalues say where the changes occurs, like in brightness, intensity, the texture, the color change. So we can say that where the changes happen, and the eigenvectors help us to find where the area that the changes has happened. So that is the tumor area. Next, go to say about advantages.
I'm Gokul. I'm going to talk about advantages and disadvantages of eigenvalues and eigenvectors. Firstly, advantages are feature distraction, feature extraction, dimensional reduction, noise reduction, and data compression. And disadvantages are depends on pre-processing, standalone improve image quality.
So next, that tell about the difference between the cancerous and the normal cells.
So first, normal brain tissue. In a healthy brain region, the tissues across the scan is uniform and predictable, and the boundaries between grey and white matters appears clearly and smooth. So this is low data variance within the region. So mathematically, it is reflected through low principal eigenvalues. Then cancerous brain tissue. In contrast, cancerous brain tissues is irregular in shape and heterogeneous texture. And
as a conclusion of the case study, so I think you people have understand so how this eigenvalue and eigenvectors plays a major role with the help of PCA concept in our day-to-day life. So not only in your biomedical image recognitions or cancer detections or noise detections, noise removing. Other than that, so it plays a vital role in many other fields. Yes, like constructions of bridges. Yes, so to analyze the vibrations. So likewise, so it plays a match your project, may I do. Thank you guys.
Thank you.